Hey everyone, and welcome to a very special explainer right here on LabVerse. I am your host, Prof. Dr. Perfectionase, founder and director of LabVerse. Now, if you're joining us for the very first time, you're in for a treat. LabVerse is an educational platform utterly dedicated to medical laboratory science, rigorous research, scientific thinking, and the beautiful pursuit of lifelong learning. Our entire mission here is to empower you with the clinical mindset you absolutely need to succeed. And the best part? We're everywhere. You can connect with our growing community across all the major social platforms. Whether you're into video explainers on YouTube, quick little science bites on TikTok and Instagram, or deep dive chats on Telegram, LabVerse is right there to support your journey. Today we're tackling something literally game-changing for medical laboratory technology and health science students: how to maximize your summer break to truly build your future. And to help me unpack this ultimate summer guide, I am so thrilled to welcome our esteemed LabVerse expert, Assist Prof. Dr. Stranger. Welcome to the Explainer, Dr. Stranger. Hey, thanks so much, Prof. Dr. Perfectionist. It is fantastic to be here. I'm honestly incredibly passionate about this topic because, let's face it, summer isn't just for resting and sleeping in. It's the absolute perfect, uninterrupted time to build a rock-solid scientific foundation and get ready for the clinical reality of the lab. I really can't wait to share these strategies with everyone today.
Assist Prof. Dr. Stranger? Okay, so let's dive right into this. We've structured this explainer as a comprehensive blueprint to show you exactly how to transform your summer break into a real launchpad for your career. We are going to cover 5 key areas today. First, the heart of healthcare. Second, the core departments and foundations. Third, we'll explore how to master the science of studying. Fourth, we'll talk about preparing for the bench. And finally, we're giving you a concrete 8-week summer roadmap.
Yeah, and that roadmap is absolute gold. If you're a student listening to this right now, you're definitely going to want to take notes, because this structure is going to save you hundreds of hours of stress later on.
All right, let's start with the big picture. Section 1, the heart of healthcare and the foundation of clinical decisions.
You know, before we get completely lost in the microscopic details of cells and biochemistry, we really have to understand the macro view. Why does the medical laboratory technology profession even exist, and why is it so absolutely critical to modern medicine?
Exactly, because it's so easy for students to just bury their heads in textbooks and completely forget the real human impact of what they're learning. What happens in the lab definitely doesn't stay in the lab. It literally dictates everything that happens next for the patient. And this quote hits the nail on the head. Laboratory data influences a large proportion of clinical decisions and forms a critical part of modern healthcare. Think about it. When a doctor is trying to decide whether to prescribe a heavy-duty antibiotic, start chemotherapy, or clear a patient for a major surgery, they aren't just guessing. They are relying entirely on the data generated by medical laboratory professionals. The stakes are incredibly high, so mastering this material over the summer isn't just about, passing your next exam. It is literally about ensuring accurate patient outcomes. You're training to be the analytical engine of the entire hospital.
So, let's firmly establish what we're actually talking about here. Medical laboratory science is formally defined as the analysis of blood, urine, tissues, and other specimens to support the diagnosis, treatment, and monitoring of diseases. And I want to point out that word monitoring because it is so crucial. We don't just diagnose a disease, say, all right, we're done, and walk away. Lab professionals track the progress of treatments over time. Is the medication actually working? Are the tumor markers going down? It's this ongoing, highly dynamic scientific investigation for every single patient.
Assist Prof. Dr. Stranger, which brings us to Section 2, Core Foundations, Building Your Laboratory Toolkit.
Before you can just casually stroll into a lab and start running million-dollar machines, you need a rock-solid scientific foundation to stand on. This is where your summer studying should really kick off. You absolutely need to master cell biology, understand tissues, blood components, microorganisms, genetics, and, of course, the major body systems.
Assistant Professor Dr. Stranger.
Right, and the fundamental reason you do this is to understand the difference between normal and abnormal physiology. I mean, if you don't know what a healthy cell looks like, how on earth are you going to identify a leukemic blast? Interpreting lab tests properly requires a really deep understanding of these underlying biological systems. You aren't just a machine operator pushing buttons. You're a scientist interpreting incredibly complex biological data.
Assistant Prof. Dr. Stranger. Now, what's really fascinating is how these foundations apply across the board. Over your career, you're going to encounter a lot of major laboratory departments. We're talking hematology, clinical chemistry, microbiology, immunology and serology, blood banking, molecular biology, and urinalysis.
Prof. Dr. Perfectionase. Wow, okay, that is quite the list. And I can totally see how that would feel super overwhelming for a new student trying to tackle everything at once. Like drinking from a fire hose, right?
Oh, for sure. But remember, the goal for your summer isn't to magically become a master of all of them simultaneously. No way. The goal is just to grasp the core purpose, the most common tests, and the clinical significance of each department. For instance, just knowing that clinical chemistry focuses on metabolic panels, while hematology is all about evaluating the cellular components of the blood, gives you a massive head start.
And that perfectly sets us up for Section 3, Mastering the Science of Studying, or as I like to call it, working smarter, not just harder.
Assist Prof. Dr. Stranger. Let's be brutally honest for a second. The sheer volume of information in medical laboratory science is just immense. It's huge. And I see students make this same mistake all the time. They'll sit in the library for 10 hours straight, frantically highlighting their textbooks in 5 different colors, and then they wonder why they fail the practical exam. Well, their methodology is completely flawed. It all comes down to the difference between passive and active learning. Passive learning is just trying to memorize isolated facts, and rote memorization simply does not work for long-term retention. What the actual science of education tells us is that we absolutely need active learning. Prof. Dr. Perfectionase.
Right. We're talking about methods like active recall, spaced repetition, concept mapping, and practical visualization.
Exactly. Instead of just passively reading about, say, an antibody screen, you have to literally close the book and actively try to recall the steps from memory. You need to use spaced repetition, which is reviewing material at gradually increasing intervals so it actually sticks in your long-term memory. You really have to focus on understanding the overarching concepts, not just the trivia.
So the absolutely crucial point here is implementing a system. You've got note-taking methods like the Cornell system, various digital systems, and flashcards. And the tools you use could be structured outlines or incredibly powerful software like Notion or Obsidian, and spaced repetition apps.
Assistant Professor Stranger.
Oh man, building a robust digital knowledge system using tools like Notion or Obsidian, that is a total game changer. It allows you to actually link your knowledge together like a giant web. So when you learn about a specific kidney pathology in your urinalysis class, you can instantly link it to the BON and creatinine tests you just learned about in clinical chemistry. This kind of organization and knowledge linking will literally save you countless hours when you're deep in your coursework.
Assistant Prof. Dr. Stranger. And you know, that structured approach completely applies to how you read scientific resources too. You cannot, and I repeat, cannot read a dense research article or a heavy textbook like it's a novel from start to finish. You will get bogged down immediately. Yes, thank you. There is a precise sequence to conquer dense texts efficiently without losing your mind. Step 1, read the abstracts to get that high-level summary. Just get the gist. Step 2, go straight to the figures and graphs. Honestly, if you can understand the data visually, you are already halfway there. Step 3, interpret the discussion section to really understand the clinical applications. This targeted approach completely prevents you from feeling entirely overwhelmed by the wall of text.
All right, let's keep moving. Section 4, preparing for the bench, going beyond the books.
Assist Prof. Dr. Stranger. This is all about translating your academic knowledge into true professional readiness, particularly for those upcoming internships. The lab is a highly coordinated, fast-paced environment, and honestly, your behavior matters just as much as your textbook knowledge. To be truly ready, you must develop professional communication and strict laboratory etiquette, but most importantly, safety awareness. Safety is completely non-negotiable in a lab handling biohazards.
Professor Dr. Perfectionase, absolutely. And beyond just safety, your attitude is key. Curiosity and asking thoughtful questions are paramount. You need to treat every single moment of your internship as a valuable learning opportunity. Don't just stand awkwardly in the corner waiting to be told what to do. Engage with the senior techs, ask why a particular protocol is used, and really show them that you are hungry to learn.
Now, beyond the immediate lab skills, there are specific professional growth skills that act like secret weapons for a new student. Improving your scientific English is absolutely crucial, since the vast majority of cutting-edge research out there is published in English.
Assist Professor Dr. Stranger.
Very true. You also need to learn how to navigate PubMed to find primary research, develop really strong Excel skills for data analysis, and start using reference managers like Zotero. Trust me, if you master these digital and research skills over the summer, you will absolutely set yourself apart from your peers the second classes begin. It's like having a superpower.
Assist Prof. Dr. Stranger. Which brings us to the climax of our explanator. Section 5, your 8-week summer roadmap, the blueprint to success. Okay, so we've talked about a lot of theory, study techniques, and skills today. Now let's synthesize everything into a concrete, step-by-step schedule. If you wake up on day 1 of your summer break wondering, what do I do today? Just follow this timeline.
In weeks 1 and 2, you're going to focus purely on the fundamentals, cell biology, blood components, and basic clinical chemistry. Build that initial biological foundation. Assist. Prof. Dr. Stranger. Then in weeks 3 and 4, you're going to shift gears slightly into infectious disease and the body's response. So that's microbiology, immunology, and urinalysis. Perfect. By weeks 5 and 6, you take a quick step back from pure biology and focus on your toolkit. This is when you optimize those study methods we talked about, practice your scientific reading, and review lab safety and professional communication. Assist. And finally, weeks 7 and 8 are all about bringing the whole shebang together. You're looking at integrated laboratory cases, like how does a patient's chemistry panel actually relate to their hematology results? You also dive into advanced topics like molecular biology and blood banking, and finalize your career and internship prep. It is literally a perfectly paced construction blueprint for your clinical mind. So, I want to leave you with this provocative thought. How will you build your clinical mindset this summer? Are you going to let the weeks just slip by, or will you use this roadmap to build a foundation that'll support you for the rest of your career? The choice is entirely yours, but I think we both know what the successful scientists are going to do. Dr. Stranger, I want to extend a massive thank you for sharing your profound expertise and guiding us through this amazing roadmap today. Your insights have been absolutely invaluable. Assistant Professor Dr. Stranger.
It was my absolute pleasure, Professor Dr. Perfectionase. Thanks so much for having me.
Thank you for joining us in the LabVerse. Follow LabVerse on YouTube, TikTok, Instagram, and X for more science, research, and learning content. Until next time, keep learning, keep questioning, and keep exploring.